UniFi Gateway's Teleport VPN is a very fascinating feature. From the UniFi network controller, you simply enable it. Then you generate a guest invite, you copy it. Then from your desktop or the mobile app on your phone, you simply run the Wi-Fi man. Then let me paste the invitation, connect. The connection has been established. So the whole process is so smooth. It only mentioned VPN, the 3 letters in the gateway side setting. It's even never mentioned in the client side. And we can assume under the hood, it's connected using VPN. There are 2 important questions we will try to answer in this video. First, what type of VPN and how the Wi-Fi man even run a VPN client. The second thing is, for this particular UniFi gateway, it's behind another router. So how the VPN connection even pass the net, okay? This is my lab environment. I have 2 UniFi gateways, UDM Pro and UXG Pro. Each one of them is behind another router. So they don't have public IP address, only the router which is ahead of them has public IP address. In this video, we will see how the teleport establish the VPN connection. We will discover what VPN is using. The answer is WireGuard. We will see. Then we will talk about if each peer is behind another router, how they even establish VPN connection. We will discuss 2 scenarios. First, by using a UDM Pro, which run UniFi network controller by itself. At the end, we will discuss if you have a cloud key and a UXG Pro, the UniFi console and the router, if they are separate, how the teleport works. Okay, a lot of things to discuss. Let's get started. Let's discuss what type of VPN teleport uses. We already established the teleport connection, right? It is still being connected. Let me SSH into the UniFi gateway to the UDM Pro. Let me first find out whether we have any tunnel interface added. So let me run IP link. Yeah, see the very last one? It's called teleport 0. It's point to point. Let's check whether this particular teleport interface lists all the processes, and I want to find the ones with teleport 0, right? There are 2 running processes. The way to read it is WireGuard through crypt to teleport 0. So the WireGuard is using the teleport 0. This already confirms WireGuard is used internally to support teleport. We can confidently check the WireGuard situation. Let me run WG. Okay, now it's 100% confirmed. WireGuard is using this teleport 0 as an interface, and it already established a active connection with this left side Wi-Fi man, right? It even lists the peer's key and the IP address for the client. Interestingly, see here, the endpoint IP address is not the remote IP address. It's not the one part IP address, the public one. Instead, it's an internal IP address. We will try to understand what's this endpoint at all later, okay? But at least from the UniFi gateway side, we confirm it is using WireGuard. The other peers side, of course, it must be using WireGuard, right? It leads to an important question. This is a regular Debian Linux. I have never installed WireGuard. I only installed this Wi-Fi man desktop. Where the WireGuard support even comes from. If I launch a terminal, let me try to find the interface used by teleport IP link. Okay, you can see the name is UTUN. It's a tunnel point to point. Then let me use similar way as in UniFi gateway. List all the processes with UTUN in it. So it confirms, yes, WireGuard is used. Then let me switch to root. If I try to search WG, remember in the UniFi gateway, we run WG, right? It comes with UniFi gateway. So let's see whether in the left side Linux client, I can find the same name command. I want to search from root. Okay, we only have one WG instance. Interestingly, it's under the Wi-Fi mains folder. It's not independently installed. It comes with Wi-Fi main installation. So behind the screen, Wi-Fi main secretly installed WireGuard. Okay, if I directly run WG, it won't run because it's not in the path. The way to run it is we directly run this. We have the regular WG information, and the interface is WireGuard interface UTUN. See, interestingly, the peer is this public IP address. It is not the right side UniFi gateway. From this WG result, we confirm, yes, Wi-Fi man also runs WireGuard, but the thing we still don't have it answered is why here the endpoint is a public IP address in the Wi-Fi man side, but why in the UniFi gateway side the endpoint is its local IP address. To explain that, we have to go to our next topic to understand how teleport works behind another router or behind net. If you have two devices, each device is behind its own gateway. The device itself doesn't have public IP address. It relies on net to get internet access through the gateway. Then how these two devices can communicate with each other. Immediately, some people may think of port forwarding. Yes, port forwarding relies on net to open a port on the gateway so that the local device behind the gateway can communicate with outside world directly. But keep in mind, teleport is a so-called zero configuration feature. So of course, opening a port on gateway is not zero configuration, right? Let's see, without doing port forwarding, how these two devices can communicate with each other. We need to talk about STAN and turn. So STAN stands for Session Traversal Utility for Net. It's a standardized set of methods, including protocol for traversal of net gateways. By using STAN, the local device can obtain information such as the public IP address of the gateway, the public port, and of course its own IP address, its own local port, and the other side information. By using this information, it can directly communicate something outside of its own local network. This video is not a video about STAN or turn, so we won't go into the details, but in some situations, just by obtaining the information we just mentioned is not enough. So the device still cannot directly communicate with the other device. If that's the case, it relies on a relay server on the internet. That server is a turn server. Turn is another protocol. It's based on STAN but with enhancement. By using this relay server, this device communicate with the relay server. The other device communicate with relay server. At the end, these two devices can communicate with each other. According to this Wikipedia article for turn, it stands for traversal using relays around the net. It can work around some limitations of STAN so that the information obtained through STAN turn can be used by all peers so that all the peers can communicate with each other. For the case in this video, for teleport, in fact, it utilized turn STAN to establish the WireGuard tunnel. Let's look into that. To have a fresh start, let me reboot the UDM Pro. Then in the lower right of the screen, I have a Wireshark session. Let me start capturing the one part for the UDM Pro. Keep in mind, the one part is still behind the gateway, so it has private IP address as well. So let me start capturing. So you can see I already have display filter on WireGuard and STAN. It doesn't have anything because the server is still in reboot process. Okay, see, right after the UDM Pro is back, we can see some STAN packets already. So you can see the .2.202 is for the one part of the UDM Pro, and this strange IP address is the STAN turn server the UDM Pro is connecting with. And you can see after several negotiations, they can establish the connection. So at this moment, this is the only turn server the UDM Pro is connecting with. So So if I stop capturing, then show all the packets. This is the first scan packet, right? After I remove the display filter, it's right before the first scan packet. See this one, DNS. So this UDM Pro asking 1111 was the IP address for global.turn.twilio.com. Then it got answer. See what's the IP address returned by DNS? It's this one, right? And then immediately the UDM Pro started the process to establish the stan-turn connection with this turn server. That's exactly what's returned as the IP address for global.stan.twilio.com. Of course, every time the gateway will receive a different IP address. Which IP address or server is returned by Twilio is controlled by Twilio, right? Even though they all have the same domain name, but Twilio can decide which exact server should be returned. Okay, so that's why now we are connecting with this particular Twilio turn server. Okay, someone may ask, we don't have any teleport connection established yet. Why the UDM Pro is communicating with a turn server? The reason is it's for remote access purpose. So here we already have teleport enabled in network controller, right? But if you go to the control plane, go to console, here there's a setting called remote access. Now because I am using remote access, I cannot disable it. But if you try to disable it by using local connection, you will see an error saying once you disable remote access, you will not be able to use teleport. The reason behind it is teleport and the remote access, they use the same technology. They use stan-turn so that they can communicate with Twilio. Okay, that's the reason behind it. And that's why here now in the Wireshark captured packets, even though we are not using teleport now, the UDM Pro is still communicating with one turn server at this moment. Okay, let's proceed to start a teleport connection. Let's see what will happen. In Wireshark, resume capturing. So at this moment, it is still only communicating with one stan-turn server, right? Then in the left side, from the Wi-Fi man desktop, from the teleport client, let me start connect to the UDM Pro. Okay, you can see in the Wireshark a lot of new stan packets, and they are communicating with a brand new stan server, this .174 server. This is a new one. Packet details, it's about turn message. This new turn stan connection is for our teleport connection. Okay, so now we see once we establish a teleport connection, UDM Pro, which hosts the teleport service, will establish a new connection to a new turn server. That's what we observed. But we still need to dig deeper to see how this new turn connection is related to WireGuard, how WireGuard use it. Let me stop capturing. We need to SSH into the UDM Pro. Then run WG. Okay, then in the left side, the Wi-Fi man machine, let me run the same WG command as I showed you previously. Okay, so now we see the peer information from both sides. From the client side, we can see this peer is exactly what we just saw in the Wireshark, the new turn server IP address, right? So this part is clear. It's just WireGuard is using this new tunnel established, and the other side, the peer is just this turn server. But from the UDM Pro side, the endpoint for the peer is showing this local IP address. So we need to find out what this is at all. Okay, let's do it. To investigate how the connection flows, let's start with this port number. So let me run netstat, find the entries with this port number. Okay, we found only one entry. The source is this exact IP address and port number. The other side is this one. We will talk about this later. Let's see what's the process is listening on it. It's teleport D, right? This confirms, yes, teleport D is doing the WireGuard connection. Let me check how the teleport D is launched. Display all the process processes and only show me the teleport D. Okay, see the teleport D is launched using these parameters. We won't take time look into all the scripts, but they didn't help us understand the process. What we know is teleport D is doing something, is listening on this part. This part is shown as the peer of the WireGuard communication. So here teleport D is listening on this as shown on the diagram, right? Now let's talk about the 600 thing. We have this port number 600. Let's search what process is listening on port 600. Okay, we only have one for IPv4 and the process name is dash. Dash means kernel. So kernel is listening on 600. As shown in the diagram, what we are talking about is this particular part. Kernel is running WireGuard, then it's communicating with teleport D. These are two peers, right? One peer is the kernel, the other peer is teleport D. Basically, we are clear about what's happening inside the UDM Pro already. Then let's see what we can find out how this part is even related to the WireGuard running in the turn server. Let me show back the Wireshark. Pick a random packet, let's say this one, from UDM Pro to the turn server. From the UDP section, I can see the port information. So destination port 3478. If you are familiar with STAN, you will know this is the port number for STAN. Then the source part is what we are interested in. It's 55063. As I marked here on the diagram. So let's find out which process is listening on this part. Okay, go back to SSH, then run the netstat command again. This time I want to see the 55063. Okay, you can see here it's only showing one for IPv6, but I believe when we capture the Wireshark packet, there should be a corresponding one for IPv4. But anyway, here from the process name, we can see it's teleport D. It means teleport D is listening on multiple ports. We already see one is for this IP address. This port number is used to communicate with the kernel about WireGuard, right? On the other hand, to communicate with the turn server, the teleport D is also listening on another port. This connection is with the turn server on the internet. Okay, so we can see the multiple roles played by teleport D here, right? So it will work with kernel on WireGuard with the turn server on WireGuard at the same time. I believe now, after the detailed investigation, we understand how the connection works. So in which step, what process from which device is involved. Now we can move on to the next topic, which is, okay, in this scenario, I used a UDM Pro. It runs the UniFi console and network controller inside the same device. But what if you have a UXG Pro? Then you need a separate device to run the network controller. For my case, I use a Cloud Key Plus Gen 2. Then whether the teleport situation will be different. Let's look into it. To understand how teleport works differently in this scenario, I launched two Wireshark. The left one will capture the Cloud Keys packet. The right one will capture the UXG Pro's one-part network packets. To have a fresh start, let me restart the UXG Pro. Then I will manually restart the Cloud Key. In the meantime, let me start capturing in the two Wireshark sessions. Okay, so now both devices are back. Let's see what's happening now. So from the left side is for the Cloud Key, right? It keeps communicating with one and only one STAN server. It's ended with 132. The reason is doing this is we enable the remote access. In the upper right window, you can see I am using the remote access way to manage this Cloud Key. So that's why we see this STAN server. It's also communicating with another STAN server, which has the IP address 217. But you can see that STAN server never responded back. Maybe that's the one previously before restart. The cloud key was connecting to that one. But anyway, the binding is not successful. So the cloud key is only connected with the 132 stand server. Then from the right side, let's see what's happening. It's a little bit busier. It's connecting with the 132 as well. Why? Remember, this is the UXG Pro. Whatever the cloud key is doing with the internet servers, it needs to go through the one part of the UXG Pro, right? So that's why you see the 132 traffic as well, and also the 217. So all the traffic you see in the left, you will see in the right. But additionally, interestingly, it has some WireGuard packet and is communicating with 174 server. But from this Wi-Fi man desktop, you can see I'm not really connecting to the UXG Pro using teleport. So this existing one, the WireGuard one you see, again, is something left over from before its reboot. The remote server on the internet still remember my UXG Pro, so it's still trying to connect, but because I don't really have an active client, the handshake was not really successful, but the remote server is just keep trying. So that's the explanation why you even see WireGuard packets here. Okay, so now we can start our teleport connection testing. So from the UniFi network controller, let me create a guest invite, copy it, paste in the Wi-Fi man desktop, connect. Okay, it's connected. Then from the right side, you can see the difference. So let me stop capturing. See, now it's connecting to a new stand turn server. It ends with 166. Why now it has a new turn server connected? Because now the teleport D is connecting to the new turn server for WireGuard purpose. The UXG Pro still runs teleport D, still runs WireGuard, but the whole process needs the help from the cloud key. In the cloud key, it will communicate with the remote access functionality, communicate with the turn server. In the cloud key, it runs Node.js. The Node.js will be responsible to communicate with Twilio to find out the new turn server. So the right side, the UXG Pro, was even able to connect to the new turn server simply because the cloud key helped it, and the cloud key completed the legwork, find out the new turn server, then send the information to the teleport, and then in the UXG Pro side, the teleport D can connect to the turn server. That's how the two devices work in this type of scenario. So if you want, you can SSH into the two devices. You will find out Telnet D and the WG are still running in UXG Pro, and the Node.js is running in the cloud key. So I won't show you the details because it's very similar to our previous scenario. But before ending this video, just to convince you, let me first disconnect the teleport. Then let me manually disconnect the cloud key. Okay, cloud key disconnected. From the top right, you can see the UniFi network controller cannot be connected because the remote access is impossible, right? Then from the Wireshark session, let me start new capturing. So you can see the UXG Pro is still continuing to communicate with the existing turn servers. But let's see whether we can establish teleport now. Let me click the Wi-Fi man's teleport connect button. So it will keep running, but from the right side, from the UXG Pro one part, you won't see new connection to turn server. You won't see successful WireGuard packets because without the help of cloud key, the teleport D connection cannot be established. Okay, so I believe we have been waiting for long enough. Now you see the effect, right? So we do need cloud key to be active so that the teleport can work. Teleport need UniFi console's help. At the end, let me mention one minor thing, but you may not expect it. If you do use cloud key, you may use it to manage multiple sites. Here you see the teleport VPN, and you may notice this site is my default site. But what if my UXG Pro is in a non-default site? Let me show you. For this site, it is not default site, but I do have a cloud key and UXG Pro, right? If I go to setting for VPN, see, you don't have the teleport option. So the teleport only works for default site. The technical reason behind it is apparent because one single cloud key can manage multiple sites. It needs to know which gateway it needs to help to connect to a turn server. That's why the ubiquitous way is it hard-coded, so the cloud key only works for the default site's gateway when it comes to teleport. Okay, this is a small thing I do want to mention. This is the end of the video. Thanks for watching.